Welcome to Scale Drawings Review, and this is Lesson 2. This is finding a scale model measurement. In our previous lesson, we discussed how to find the measurement of an actual object given the scale, what one measurement on a model represents on the actual. So the scale is what one measurement on a model represents on the real. We also looked at 3 different methods to accomplish this. Today we will discuss how to find a measurement on a scale model and scale drawing if we are giving the actual measurement of the object. Finally, we'll discuss how to find the scale factor if we're given measurements for both the model and the actual. So far, our first lesson, we were given the scale model measurements and found the actual. Today, we're going to be given the actual measurements and we're going to find the model measurements. And then we're going to continue where they tell us both the measurements of the model and the actual, and we're actually finding the scale, which we know as the scale factor or unit rate. So that's where we're heading. Let's start first now, and because we're going to try this using 3 different methods, and you get to choose the method you want to do, we're just going to label this. This is going to be method 1, this is method 2, and this is method 3. You're going to decide which one of those methods you prefer. All right, our first situation, a model statue has a scale of 3 centimeters to 21 meters. If the real statue is 14 meters tall, then how tall is the model of the statue? So let's highlight that information. They mentioned the scale was 3 centimeters for 21 meters. They mentioned the real, or the actual statue, is 14 meters tall, and they're asking us to find the height, how tall is the model. So we know this so far. We know that the centimeters must be talking about the model, and the 21 meters must be talking about the actual. They gave us their actual, and then we're asked to find the model. That's what we don't know. So we're going to start the very first way talking about a proportion. And right off the bat, they told us 3 centimeters, and I want to label because it will help me make my other ratio, to 21 meters. So this is the model, this is the actual. And that's going to equal the model measurements, which we don't know, so I'm going to choose an X. We don't know that. That's what they've asked us. And so we do know that it should be in centimeters, though, because that's the unit of measure they gave. And then we're told that it's 14 meters. The actual statue is 14 meters. So now we have a proportion, and we can cross multiply. It doesn't matter which wing you start with. I'm going to start with this because it's going to have my x. 21 times x would be 21x. This body says to drop down the equal. And we're going to take 3 times 14. And 3 times 14 is 42. Having your calculator handy will be helpful. Next, now I have to solve, because what I want to know is I want to know what x, which is the model measurement, is. So I do that. Side by side means multiply, so I'm going to divide on both sides. So I can eliminate the 21, and that's going to give me x equals 2. So now I have to figure out what 2 means. Well, 2 is centimeters. So it's to answer the question, the model is 2 centimeters, and I got that because I labeled tall. So now we know our answer. And if I look at this, if I use my logic, 3 compared to 21 and a number compared to 14, well, since the 14 is smaller than the 21, I'd expect that its number, the corresponding number, should be smaller as well. So this number should be smaller than 3. So now we're going to go over to the next version or next method. This is the chart method. And the very first thing we have to find using the chart method is we need to find the scale factor, or the unit rate. So the scale that we're given, and let's go ahead and we'll even put it in the table. We have an X and we have a Y. And in this case, the X is talking about centimeters. This is the model, 3. And the Y is talking about meters, which is, and I'm going to put meters who don't think it's a model, it's 21, and that's the actual. So we have centimeters and meters, and to find the scale, we use the unit rate. We take the Y measurement, which is 21, and divide it by the X measurement, which is 3, and that equals 7. So we're going to use that 7 to go across the table. So let's see what other information they gave us. If we look, they told us 14 meters. Oh, so that 14 meters needs to go on the right side of the table. And what I'm trying to figure out is the centimeters. So we're going to now use this scale, but since we're going backward, we're going to divide by 7. So we're going to use that 7 and divide by our scale factor. So 14 divided by 7, that's going to give us 2. And that's the same number that we had first time. So that's the chart, our table method. Finally, we're going to go to the equation. And the equation is the rate, which is the scale factor, times the model measurement. And that's going to equal the actual measurement. So rate is the scale, M is for model, and A is for actual. So if we use this, and by the way, this is just another version of Kx equals Y. It's just another version. So if you want to think of it this way and look at our table, we have our X's and centimeters, our model, and our Y and meters are real. So we've already found the scale factor, so where the R is, I'm going to put 7. I'd have to do this part if I'm going to use the equation, regardless if I use the table. Then I would multiply the model measurement, but that's what we don't know. We're trying to find our model, how tall is our model? And then that would equal the actual measurement, which they gave us, which is 14. So they gave us that information, so 14. So now that I look at this, I realize I have to solve it. So I'm going to divide both sides by 7, and sure enough we divided here, and I'm going to get M equals 2. Well, all 3 methods we found 2, and you're going to decide which way you prefer to do this. If we use the chart method or the equation method, we have to do this step, this scale, finding the scale, which is really the unit rate. It is really a Y value divided by the X value. So it is the scale that they gave us, but we just take the second number divided by the first number. All right, let's try another one together. Number 2 says, a map uses a scale of 1.5 inches, or 1 5/10 inches, equals 60 miles. If the distance between Buffalo and Albany is 290 miles, what is the scale distance on the map? So let's highlight important information. We have 1 5/10 inches equals 60 miles, so 1.5 inches equals 60 miles. And we have that the distance between Buffalo and Albany is 290 miles. Then it asks us, what is the scale distance? So let's put this into perspective. If we're going to use the proportion method, we want to know that this is the model and this is the actual. And if we use the chart method or the equation method, it might be helpful to know this is the X and this is the Y. And so when I look at it, the miles is the actual, or in other words, the Y. So let's start by acknowledging we're going to try 3 different methods, and then we'll go from there. So our first method is the proportion method. So we want to write what they've given us, and the scale is very helpful. It immediately gives us a ratio, a comparison of 1 5/10 inches compared to 60 miles. And now we need another ratio. We don't know the inches. That's what they've asked us to find, the scale distance. And then we do know that there's 290 miles between Buffalo and Albany. So now we have our proportion. We are now ready to cross multiply. So it doesn't matter which one of these you particularly start with. I'm going to start with 60 times x because that one's easiest to do in my head. And then we're going to take 1.5 times 290. So pause and complete that on your calculator. And hopefully you have 435. Next, we need to solve this. We are going to divide both sides by 60. So, calculator handy again. The 60 divided by 60 eliminates, leaving x. And now 435 divided by 60 is 7.25. So, let's see if this is a reasonable answer. Since we started with a decimal, and this number is a decimal, that would be that would make reason. We could have decimals in these answers. Also, 1 and 5/10 is not very far from 7 and 25 hundredths. That makes sense that it was bigger because we started with 60 and then went to 290, which is bigger. So this seems like a reasonable answer. So what did we just find? We found out that the scale distance is 7 and 25 hundredths inches. That's our label. Okay, so on a map, that's how much it measure if we had a map that had that scale. So now let's move forward and move on to the second way to do this, and this is the chart. The very first thing we need is we need to use the scale. However, we're not going to use it in the order that they gave it to us. They gave it in this order, and that's how we set it up in the proportion. We started what they gave us over the second. But when we are finding the scale or the unit rate, we're going to put the y value, the second value, over the first value, the x value. So we want to take 60, which is the y, or the second, the actual miles, over the x, which is the model measurement. So you pause this and use your calculator to calculate the scale. All right, and we take 60 divided by 1.5, we get 40. So that's our scale, otherwise known as our scale factor. So we are now going to build our chart. And our chart, remember, is the first thing they talk about is inches. This is our x. And then they talk about miles. This is our y. And they gave us 1 and 5/10 inches, and they gave us 60s. And then we took that and we created our scale from that. Now, what they're asking us is they have given, or this is what they've given us. They've mentioned 290, and I put it in the miles because it's miles. And we want to know what the measurement is on the drawing, which is in inches. So since we're moving on the chart, we're going from the y to the x, we're going to divide by 40. So again, pause your calculator, take 290 and divide it by 40. And hopefully you have the same number that looks familiar. It's 7 and 25 hundredths. What do we find? Well, the nice thing about this chart is it's labels that it's inches. So we found the same thing. We found the scale distance on the map. Finally, our last method, and that also involves a scale. So if you're going to do this exclusively, you're going to have to start this scale just the same way. You're going to take the actual and divide it by the model, and that should be 1.5, and we're going to get 40. So we just got done doing it. But we need that because we're going to replace each one of these variables, if we can, with one of these parts. And this is the rate, R for rate. The scale is the rate we're looking at. So right here, we're going to replace it with 40. The the model, and this is not miles, that's where the variables get us in trouble sometimes. It's the model, and we don't know the model measurement, so I'm going to use x in this case, but we are given the actual. We're given 290. So if once we have this set up, we're going to divide by 40 on both sides, and since we just did that right here, we divided by 40, we have x equals 7 and 25/100. So we are not going to find the scale factor today. We're going to save that for another day. So would you please now go to the practice set? There's 2 problems I'd like you to try on your own. Thank you.